South Kazakhstan State University, Information Technology and Energetic Scientific School. Welcome to our laboratory work, dear students. My name is Halimova Bigzada. I'm a teacher at the Department of Information, Communication and Technology. Computation of metrics of productivity of computer system, speed, efficiency, energy expenses, Amdahl's law, CPU, time. The aim of this class is to provide students with an idea of information in a computer understanding information units, basic concepts of translating numbers from different number systems. The learning objectives. Having studied this theme, the student will be able to positional and non-positional number system, basic concepts of positioning systems, the base, the alphabet, expanded form of representation of numbers in positional systems, translate numbers from one system to another, know information units. Key questions of the theme. What is information? What kind of information computer uses? What is the form of presentation of information? What is a numerical system? What is the unit of measurement of information? What is a binary number system? When using a binary number system. Methods of learning and teaching. Presentation, in-depth work, task, and test. Have you ever heard of words bits and bytes? Have you heard of an advertisement that says this computer has a 64-bit Pentium 4 processor with a 256 megabytes of RAM and 100 gigabytes of hard disk space? Probably the answer is yes. Even for a normal computer user, not to mention you, a C++ programmer. As a computer programmer, you should know what bits and bytes are and how to work with numbers expressed in binary and hexadecimal notations. In this laboratory work, we will discuss bytes and bits, binary and decimal numbers in detail, so that you will gain a fundamental understanding about their meanings, what these systems are and how they work. To help you understand, let's first review the well-known decimal number system. The decimal system is the base 10 system that we use every day. A number, say, 6,357 represented in the base 10 system consists of multiple ordered digits. In other words, digits are normally combined together in groups to create larger numbers. A digit is a single place that can hold numerical values between 0 and 9, 10 different values. For example, 6,357 has 4 digits. It's understood that in the number 6,357, the 7 is the filling first place, while the 5 is the filling 10th place, the 3 is the filling the 100th place, and the 6 is filling the 1000th place. Another way to express it will be to use the concept of power of 10. A specific digit is associated with a specific weight expressed as powers of 10. The first digit, counting from the right, gives 10 to the 0 power. The second digit gives 10 to the 1 power, and so on. Exponents are the shorthand way to show how many times a number called the base is multiplied times itself. A number with an exponent is said to be raised to the power of that exponent, assuming that we are going to represent the concept of raised to the power of with the squared symbol. 10 squared or 10 to the power of 2 is written as 10 squared 2. 10 to the fourth power is denoted 10 squared 4. But why do we human beings use 10-based number system? The most commonly accepted explanation is that our base 10 number system was adopted by our ancestors most likely because we have 10 fingers. Interestingly enough, maybe I read that is why digit in English also means a finger or toy. We have reasons to ask a question in our mind. If we happened to evolve to have 8 fingers, instead would we probably have a base 8 number system? The answer is probably yes. Bits. The binary number system uses binary digits, bits, in place of decimal digits. A binary number is composed of only zeros and firsts, like this: 1, 0, 1, 1. How do you figure out what the value of the binary number 1, 0, 1, 1 is in decimal world? How does it work? As we have shown that our decimal system is based on place or location, there is the place of each digit decides the value of that digit. The binary system works in exactly the same way, except that its place value is based on the number 2. How you count or add in decimal? Considering the decimal number system, it has a set of values which range from 0 to 9. If you add 1 to 9, carry will happen. X plus y is greater than 10 and carry 1 onto the next column of the left. If the sum is less than 10, put it down at the bottom and set the carry to 0. If it's not less than the base, subtract 10, put down the result and set the carry to 1. With only two numbers 1 and 0, counting in binary is pretty simple. Just keep in mind the following: 0 plus 0 equals 0. 0 plus 1 equals 2, 1. 1 plus 0 equals to 1. 1 plus 1 equals to 10. When you look at the sequence, 0 and 1 are the same for decimal and the binary number system. As for the decimal number 2, you see for the first time carrying takes place in the binary system. If a bit is 1 and you add 1 to it, the bit becomes 0 and the next bit becomes 1. The hexadecimal system. Also, not a problem. Internally long binary number seems a problem to display in some situations. A common practice to solve this problem is to use hexadecimal to represent binary numbers more compactly externally. The hexadecimal system is base 16. Therefore, it requires 16 different symbols. The values 0 through 9 are used along with the letters A through F, which represent the decimal values 10 through 15. The octal system is base 8. Therefore, it requires 8 digits. The values 0 through 7 are used. Octal to hexadecimal conversion or vice versa is most easily performed by first converting to binary. The binary, hexadecimal hex, and the octal system share one common feature. They are all based on powers of 2. Each digit in the hex system is equivalent to a 4-digit binary number, and each digit in the octal system is equivalent to a 3-digit binary number. Why are there 8 bits in a byte? A similar question is why are there 12x in a dozen? Why your table has no large or smaller working area? It targets at the most common situation. The 8-bit byte is something that people settled on through trial and error over the past 50 years. To some extent, 8-bit is enough to represent all English characters and Arabic numbers. A byte used to be the basic unit to hold an individual character in a text document. Okay, students, there are control questions for your home task. How the signs of numbers in the computer are encoded? What is the difference between byte and bit? What is the coding information? What does a computer need memory? What is the best type of storage for my data? What factors affect a computer's screen display? Are ink jet printers better than laser printers? What is the best way to add devices to a computer system? How can I protect my computer system from theft and damage?